Adapting SCADA for an IP. As we see on the screen, the protocol stack for transporting serial DNP3 SCADA over an IP. We can see here that a 7-layer network, data link layer, network layer, transport layer, where this connection management is going to happen. Next comes the upper layers, DNP3 data link layer, DNP3 transport and function layer, then DNP3 application layer, DNP3 with IP layers. As this IP network, so here the serial protocols are adapted and evolved to utilize IP and TCP or UDP as both networking and transport mechanisms. DNP3 protocol, that is distributed network protocol, is based on a master-slave relationships. That is, the master is referred to a powerful computer located in the control center of a utility, and a slave is a remote place device with computing resources found in a location such as substations. Now DNP3 refers to slaves as outstations. The outstation monitor and collect data. Outstations monitor and collect data from the devices that indicate their state, such as whether a circuit breaker is on or off, and take the measurements including voltage, current, temperature and so on. This data is then transmitted to the master when it is requested, or the events or alarms and control commands can be set in an asynchronous manner. The connection management links the DNP3 with the IP layers. You can able to see here. This is a connection management. Okay. Links IP layers as well as DNP protocol. In addition to the configuration parameters and methods necessary for implementing the network connection, the master side initiates the connections by performing a TCP action plan. TCP active open. The outstation listens for the connection request by performing a TCP passive open. Now, master stations may possess multiple DNPs, data link layer frames, from a single UDP datagram, while DNP3 data link layer frames cannot span multiple UDP datagrams. For the single or multiple connections to the master may get established while a TCP keep alive timer monitors the status of the connection. Like this, the connection between DNP3 and IP communication works. Now, the tunneling legacy for an SCADA over IP. The end-to-end connection, how that it happens. Okay. Here the end-to-end native IP support is preferred in the case of DNP3. Otherwise, transport of the original serial protocol over IP can be achieved either by tunneling using raw sockets over TCP or UDP by installing an intermediate device that performs protocol translation between the serial protocol version and its IP implementation. You can see here in the picture that how the raw socket between routers, no change in the SCADA server. Okay, how it works directly in the TCP or UDP transport. Here a socket is standard application programming API. It is interface composed of IP address and TCP or UDP port that is going to be used to access network devices over an IP network. Now you see in this the serial interface is there, then infrastructure IP is there, raw socket master and client setup router is there. All it leads to the serial interface for the SCADA server. Application communicates through COM ports. It has the scenarios A, B and C. The routers connect via a serial interface to the remote terminal units, RTUs, remote terminal units, which are often associated with SCADA networks. This RTU is a multi-purpose device used to monitor and control various systems, applications and device managing automation. From the master or slave perspective, the RTUs are the slaves. That is, remote terminal units are slaves. Opposite to the RTU in the SCADA server, a master that varies its connection types. The scenario A, if you consider a raw packet between routers, there is no change in the SCADA server. Both the SCADA server and RTUs have a direct serial connection. This is a direct serial connection to their respective routers. So the router terminates the serial connection at both ends of the same link and use raw socket encapsulation to transport the serial payload over the IP network. Second scenario is a small change on the SCADA server side. A piece of software is installed on the SCADA server that maps the serial COM ports, communication ports, to IP ports. So this software is commonly referred to as IP serial redirector. The IP serial redirector is in essence terminates the serial connection of the SCADA server and converts it into TCP IP port using raw socket communication. There are serial interfaces are there, IP infrastructure is there, where the raw socket master and client setup is between the routers and the SCADA server is existing. One addition that it is made here, the application communication through COM ports mapped to IP plus